we're going to discuss another application of special right triangles. Now, you just got to trust me, these two triangles and these relationships come up tremendously in science, in math, in construction, lots of times. So let's take a look at another example here where they come up. So I'm going to go back to, let's just draw a triangle, and we'll make this a 30, 60, 90. Let's just do that one angle down there. Now, this is a 30, 60, 90 triangle. Let's give the sides. Let's call this side length 1, this side length 2, and call this one root 3. What is the sine of 30 degrees? And remember, sine theta is opposite over hypotenuse. Here's 30 degrees, so that's going to be opposite over hypotenuse, so sine of 30 is 1/2. You can actually check this on your calculator. Sine 30 equals, you get 0.5 or 1/2. With our special right triangles, we can do sine, cosine, tangent of 30, 60, you can do 90 also, and 45, and we should be able to get the exact value. Now by exact value, I mean, if you do the sine of 60 degrees or the cosine of 30 degrees, you will get a non-repeating decimal or a irrational number. Now let's take a look at what that's actually going to mean. So let's do the cosine of 30 degrees. Okay, so back up. Sine, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Cosine 30 is adjacent over hypotenuse. Okay? Now, the square root of 3 is an irrational number, so you'd have non-repeating decimals. However, this is the exact answer. Okay, that's exact. Again, if you go up on your calculator, you type in cosine 30, you get 0.866, something like that. Well, this is the right answer. This is the answer that I'm going to be expecting to be shown, not a decimal. Okay, finally we can do the other one. We have sine, cosine, let's do tangent. Tangent of 30 is going to be opposite over adjacent. That's 1 over the square root of 3, which we can't leave the square root of 3 down here. We have to rationalize that, and so we're going to multiply this by root 3, Square root of 3 times the square root of 3 is just 3. So we end up with root 3 over 3. Okay, so you can go through this and you can determine the sine, cosine, tangent for all the angles. Let's take a look at that. Let's do sine, cosine, tangent, and we'll do it for 30, 60, and 45. So we already did sine of 30, that's 1/2. And then root 3 over 2. Well, we can do it for the other ones up here. Oh, tangent. Oh, shoot. I got that wrong. Sorry, we're on 30. Okay. We can do the same thing for the 60, which is this angle up here. So this is 60 degrees. So the sine of 60 is opposite over hypotenuse, so it's going to be root 3 over 2. And the cosine of 60 is going to be adjacent over hypotenuse, which is 1/2. Hey, I'm going to stop here for a minute. Look at this. Those two are the opposite of those two. The cosine of 30 is the same as the sine of 60. And the cosine of 30 and the sine, these guys are opposite. Well, it turns out they're opposite because they're called complements. This guy, cosine is called the complement of sine. That means they add to 90. And so there's some actually math we can do in here to show you that. But the sine and cosines are opposite with the complementary angle. So you can see that relationship. Okay, let's do the last one, tangent of 60. So tangent is opposite over adjacent, so it's going to be root 3 over 1. Okay. And the last one's going to be the 45, 45, 90 triangle. And let's see, it's going to be, let's call this one 1 root 2. So the cosine, or the sine is opposite over hypotenuse. And again, we can't leave a square root in the denominator. We need to rationalize it. We're going to multiply it by root 2. And your root 2 over 2. We can do the same thing for the cosine, adjacent over hypotenuse, and we get root 2 over 2, which should not surprise you that the cosine and the sine of 45 are the same. And finally, the tangent is opposite over adjacent. That's just 1. Now it's through these relationships we can actually draw quite a few conclusions. But for right now, I'm just going to stop right here. I wanted to show you we can get the exact value for sine, cosine, tangent of at least these angles. Later on, you're going to see we can do other angles too, but we'll just start with these that came from our special right triangles.